Welcome to InventorCAM Professor on a series of Getting Started. I'm Sydney, your InventorCAM Professor, and in this session we'll be going over the automatic recognition such as drill and pocket recognition. If we take a look at the part on our screen, you'll see that there are many holes that have to be drilled out over here, and we have also these pockets such as this deep one down here, which is a closed pocket, and also these areas which are actually open pockets. Now, let's see how we've machined this particular part here. Now, my first operation, before I even started working on the pockets themselves, I did a simple face machining over the top. And if we look at the operation itself, you'll see that my geometry is the border around the part itself. The tool that I've used is a 38mm end mill, and the technology that I'm using is a hatch technology. And if I run my simulation, you'll see that the tool will simply go back and forth on the part, covering the entire part itself all the way across. Now, in my next operation, we've done the pocket recognition. If I open up the operation, you'll see the follows. If I go into define, you'll see the following things. First of all, we have all these changes that were defined automatically. This was done by choosing the option of solid body, select mode of solid body, and also we have here what we call minimum diameter. In other words, anything that is smaller than any diameter that's smaller than 17mm will not be taken in as a pocket. We've also clicked on through pockets. For any pocket that's a through pocket, such as this one over here, to take those also into account. As far as the tool goes, I've used a 20mm end mill, and my levels, you'll note that there is an upper level, but there is no lower level. The depth is automatically controlled from the part itself, automatically recognizing the depth of every single pocket. In my technology field is exactly like a regular pocket, using options of contour, if there are open pockets, working on an open pocket area, and so on and so forth. And my links exist also exactly like any other pocket. If we take a look at our simulation now, and we use the solid verify simulation, you'll see that the tool will clean out every single area, including these holes which were bigger than 17mm. Also clean out every single pocket area, including the open pockets, as you can see over here. And every single area is being milled out according to its individual depth, including these slots, including this pocket in the middle, without missing any of those areas at all. Going down to the very holes over here as shown on this side, and also not to forget this particular hole over here as well. In the next operation, I'd like to start working now on these holes over here. And as you can see, we have holes with all different types of diameters. And the first thing I'd like to do is I'd like to just pick up every single hole that we have here and drill with a center drill, with a 90-degree center drill, that will spot drill, I should say, that will automatically recognize the spot for every single one of those holes and drill down just to the diameter of the hole itself without going further. In my operation itself, what I've done is as follows. My geometry in this particular case, if I go into if I show you the option itself here, you'll see that every one of the holes were picked up in my geometry. The tool that I'm using will be a 10mm 90-degree spot drill. In my levels, we have depth edit. Now, normally what happens is the depth and the height of the tool of the holes are picked up automatically from the part. If I go, however, into my depth edit, you'll note that we have everything broken up into different groups as shown over here. What I've done is as follows. I've had each group go down to a depth. I've edited them all to the depth to be at 0 height for that particular hole. And in each group, I've told it that I want the 0 depth to go down to that particular hole's diameter. In other words, only 6 millimeters of the diameter of the tool will get to that 0 depth. And I've done it for every single group. In this particular group, it's 7.5. And in this particular group, it's 4 millimeters. If I take a look now at my simulation, and again, I'll use my solid verify simulation, you'll see that the holes are drilled exactly according to the size of each one of those holes. This one here being larger, this one here being smaller, and so on and so forth, according to the exact size of every single one of those holes. Now, this was done all in one operation. In my next operation, I've decided to drill out these holes over here, as shown in this part over here. And again, I've used the option of drill recognition. If I were to go into my operation itself, as you can see, my geometry picked out those particular holes, as you see here. My tool is a 13.5 millimeter drill. That's the diameter of that particular hole. The levels in my depth edit, this was automatically put in there according to the height of that particular, the height of that, the upper level of that particular hole. And the drill depth was put in here automatically also according to the depth of the hole itself. What I've added here was, one, I've added a delta depth to the entire part, having the drill go down an extra millimeter down, further down, and I've also checked off the option of and choosing full diameter for this part itself. If we go into our simulation, and again, I'll use the option of solid verify for our simulation, you'll see that the tool drills down every single one of these holes, and only those holes to the full depth of that particular hole. Now, in my next operation, I've decided to drill out these holes over here, all of these small holes over here as shown. Again, what I've done is just like I've done in the previous operation. I've chosen my geometry, and my geometry again are those particular holes only, as shown over here. And if we go into the area moment, you'll see that we're talking about holes that are through and blind to find all those holes. And we've only used, however, not every single one of the holes that's on the part itself, but only ones of this particular shape here and this group. And the rest of the group of holes we've not used at all in this particular operation. I've chosen a 6.5 millimeter drill. Now, in my levels area, again, I'll go into my depth edit, and you'll see that the upper level and the drill depth are the exact same way they were in the previous operation, which was taken automatically from the part itself, being that this upper level was the same as this one over here, the previous. The delta depth, again, I'll be using to go past that hole by 1 millimeter, and I've chosen the option of full diameter, so the full diameter of the tool goes past that particular area, past the depth itself. If I would take a look at the simulation, you'll see, again, using the solid verify simulation, that every single one of those holes are being drilled out, as shown here, and they're going through to the very bottom of the part itself without missing a hole at all.
Now if we go down to our next operation, you'll see we basically did the same thing for these particular holes over here. And in this operation, we've done also the same thing for these holes, as you see over here, just as well. Basically, we follow the same pattern for each one of these types of operations. Let's just open up one more operation, such as the last one over here. And if we take a look, the particular holes that I'll be going into will be these holes over here, as you see them forming now. These particular holes over there. The diameter will be a 4.2 millimeter drill. My levels, if I go into my depth edit, you'll see that we have our upper level and our drill depth automatically from the part itself. And in this particular case, since it's a blind hole, just leaving it at the cutter tip. And if I just look at the simulation, and again I use the option of solid verify in my simulation itself, you'll see that every single one of those holes was drilled out as shown here, exactly according to the depth of each one of those holes.
Thank you for joining us on InventorCAM Professor. Take care and have a nice day.